Alright, so in this video, video 6.1, we're going to talk about the end behaviors of a graph. So end behavior is this fancy notation in blue. In blue is what the actual notation looks like, and in black is me translating the math to English. So in blue, the first bullet says as x approaches, so that arrow just means approaches. So as x approaches negative infinity, y approaches what? Or another way to say it was as x goes all the way left, so if we just go left forever, what's happening to y? My options are y is going to positive infinity or negative infinity. Technically, in behavior could be a number, but that's going to be really rare, so we're not even going to worry about that. But we're going to be filling in the blanks in the blue, and we're just talking about as x approaches positive or negative infinity, what is y approaching? All right, so while we get into end behavior, we're also going to get into even versus odd functions. So even functions look like this, and what I mean by even is like x squared, or x to the fourth, or x to the sixth, where my exponent, for our purposes, where our exponents are even. So let's do the one on the left. So the one on the left, for the first blank, it says as x approaches negative infinity. So as we go left forever, is my graph going up or down? And my graph is going up. So y is approaching positive infinity. So as x goes to negative infinity, or as x goes left forever, my y values are going to positive infinity. So as x approaches negative infinity, y approaches positive infinity. For the second blank, it's as x approaches positive infinity. So as we go right forever, is my graph going up or down? So as we go right forever, my graph is going up. So y is approaching positive infinity. Positive infinity for both. Now, how do we determine if the leading coefficient is negative or positive? So we have two options. We can, one, remember what an x squared function looks like, and it opens up if a is positive, or the negative out front means that we have a reflection. So in this case, my leading coefficient is positive. Another way to look at it is, where is the right arrow going? So here, no matter what function I give you, where is the right arrow headed? This right arrow is headed to positive infinity, so the leading coefficient is positive. All right, let's go to the second one. So in the second one, as x approaches negative infinity, so as x goes left forever, my graph is going down, so y is approaching negative infinity. As x approaches positive infinity, so as we go to the right forever, my graph is also going down. So here, for leading coefficient, to determine positive or negative, look at that right arrow. So right there on that right arrow, we're going down, so my leading coefficient is negative. I know with x squared we may not need to use the right arrow trick, but if our graphs become more and more complicated, that may help. All right, key thing for end behavior. The end behavior of even functions is the same. So if I ask you in the future, is blah, blah, blah an even function, you just need to see, are the arrows pointing the same direction or not? So odd functions. I just said that even functions point the same direction, and if you look at these odd functions, the arrows are pointing in opposite directions. That's how we can determine even or odd without even knowing the equation with just looking at the graph. All right. So the first says, as x approaches negative infinity, so as we go left forever, my graph is going down, so y is approaching negative infinity. And as we go right forever, we're going up, so y is approaching positive infinity. Now, leading coefficient positive or negative, this is one that may be a little more confusing because this graph we haven't seen before. So leading coefficient, we're going to look at this right arrow. So if I look at the right arrow is going up, so my leading coefficient is positive. All right, last thing. So here we have as x approaches negative infinity, so as we go left forever, my graph is going up, so y is approaching positive infinity. As x approaches positive infinity, or as the graph goes right forever, my graph is going down, so it's approaching negative infinity. And then here, we look at my right arrow. My right arrow is going down, so my leading coefficient is negative. Now, with even functions, we saw that the end behavior is the same because the arrows point the same direction. With odd functions, the end behavior is opposite or different in each blank because the arrows are pointing in opposite direction. So there's end behavior.